Okay, this is the guide on a possible way of doing an experiment to have a look at the angle between the rotation of the mirror and the angle of a reflected ray. A very, very simple version of this experiment would be to take a mirror and your ray box. Now your ray box gets hot. Now, so if your ray box is getting hot, you'll need to switch it off when it's not in use for safety purposes. Obviously that would go on any good risk assessment. I'm going to just switch my ray box off for a brief moment because I'm going to prepare my A3 sheet of paper. I've got a nice big sheet of paper, I've got a pencil, I've got a mirror, I've got a ruler, and I've got a protractor. The job of the ruler is basically to make sure I've got nice straight lines. That's a first key. So I'm going to draw my control variable, which is going to be the direction of my reflected ray. So I'm going to draw it nice and clearly there. Now, I'm using a slightly blunt pencil so that you can see it more easily on camera. Obviously, you need to make sure your pencil is quite sharp. And what I'm also going to do is I'm going to draw a line at 90 degrees to this. So I'm going to take my protractor, put the cross wire on the end of the line, and then put in a tick at 0 here and at 180 here. And this will mark my reference for my angle of the mirror. You'll see why that is in a brief moment, so don't worry too much about that for now. But it's one thing you might want to do when you're doing your experiment is to make sure you've got that great big letter T there. Makes life a lot easier later on, you'll see. So the idea is this, that if I take my ray box and I shine a light along here, it'll reflect off the mirror, and I want my reflected ray to go along here. The only way I can do that is by adjusting my angle of the mirror. So let's make some nice reference lines. Now I've decided in my experiment, I've decided to change the angle every 10 degrees because 10s are nice and easy to work with. So I take my protractor, I put my line along the 90, and every 10 degrees I make a nice little convenient tick along here. And I'm probably going to go up to about 70 degrees. For now, well, I'll put the 81 in just for good measure for later on. So I'm going to draw in now my incident rays. I'm going to draw these in a little bit lighter so I can tell the difference, okay? So I'll draw in my incident ray here, and here, and here, and so on, until I have all of my incident rays already plotted. Notice how they all go to the same point, okay? It's very important in my experiment because that's so that I've got everything sort of set up and ready to go, really. Okay, looking very nice. I think I'll do that one and I'll skip the last one for a brief moment. You can do as many or as few as you like. I'd recommend probably every 10 to 15 degrees for this particular method. You may choose a different method. This is just the one that I'm using today. So I'm going to place, first of all, my ray box, and I'm going to make my first incident ray. So I say that my first angle, A, here, is going to be 10 degrees. Okay, so I'll just write it there as 10 degrees. I shine my incident ray along that line. Notice how the ray of light goes along that line. And then the difficult bit, the fiddly bit, is to take the mirror and then change the angle of the mirror so that the reflected ray goes along my reflected ray line. Okay, so there's my reflected ray line, goes along it, and I'm just going to make a little mark at the end of my mirror. Make a little mark at the end of my mirror, just there. And I make a little mark just here. And I'm just going to join it up first of all. So I'll just join it up. Nice line there. So that's the angle of my mirror there. And this angle here that I'm going to measure here, that's going to be my angle B. Okay? So I take my protractor and I very, very carefully measure the angle through which I've had to rotate the mirror in order to get it to shine along that control line there. And that I make it to be exactly 5 degrees in my particular experiment. Yours may differ. So your B is equal to 5 degrees, and let's now do another angle. Now, I'm going to skip a few. Obviously, in my experiment, if I was doing the whole thing all the way through, which I think would probably bore you a little bit if you just to watch me do it, it's probably easier if you just follow if you just get the gist of what you're supposed to do and then have a go at doing it yourself. Okay, no substitute for trying it out. So here I'm going to take my angle here, which that's 10, that's 20. Here my angle A here is going to be 30 degrees, and I'm going to see how that might be different than 10 degrees. So I shine my light along here, take my mirror, and I position it again so that my reflected ray goes along my reference ray. And I've got to try and make sure that my mirror lines up with that sort of join between the two lines there. So I'm just going to make sure it's lined up perfectly. Obviously, a big source of inaccuracy here is the fact that this ray here is quite wide. So I'm trying to sort of aim it down the middle if I can. So all I do here is I do one sort of tick there, one tick there, take it away. I've got my two little marks. So it's got to go through here, here, and here as best as possible. Here we go. And just make sure it's exactly right. Draw my line very carefully. There it is. So now measuring the new angle that I've rotated the mirror to get a new corresponding value of B. Okay, so I'll take my protractor. I rotate my protractor round. I keep the cross wire on the join between the two lines here. And I measure my angle very, very carefully. 5, 10, 15 degrees. So here, my B equals 15 degrees. So just to show you the technique one more time, because you've seen it once, you've got the gist. You've seen it twice, you're beginning to sort of think about some of the finer points. Now, if I show you my method a third time, you'll have a clearer idea. So let's now take the angle to be 40, 50, 60 degrees. Okay, so A equals 60 degrees just there. And all I'm going to do is I'm going to shine my light along that line. So you take your ray box, you shine the light along that line, there it is. You take your mirror, now as you can see at the moment it's not going along there, so I rotate my mirror. How far have I had to rotate it? I've got to be quite careful here, it's not easy to do. There we go, that'll do nicely. Almost there, just about there-ish. You can see that because of the difficulties with positioning the mirror, it can be very, very difficult to measure the angle. So you've got quite another source there of inaccuracy in your experiment. Okay, always well worth noting what your source of inaccuracy are. So let's have a quick look. That goes there, that goes there. Measure my new reflected ray goes there. Okay. And again, I measure the angle. So I'm very careful. Take the cross wire, put it on where the lines all join up. I've got this one slightly off today, this one. So I put the 0 along here, and I make it 29 degrees, okay? And I suspect that's because I haven't really drawn my position of the mirror very well there. Okay, so that is roughly how I've taken my independent variable to get a corresponding dependent variables. So for an angle of incidence of 10 degrees, I had to rotate the mirror 5 degrees. For an angle of 30 degrees between the incident ray and the reflected ray, I had to rotate the mirror 15 degrees. And to have an angle of 60 degrees between my incident ray and reflected ray, I had to rotate the mirror 29 degrees. And that gives me some results. Now, if you do that for every 10 degrees, you'll have 1, 2, 3, 4, 5, 6, 7, 8, possibly even 9 sets of readings, which is more than enough for what you need for doing these experiments. The next video, I'll show you what you do with the data.